There are many different types of audio effects which can be created by delaying a signal over time. The first category we're going to look at are echo effects. In this case, a listener will perceive one or more distinct repetitions, or echoes, of a signal. Later on, we'll come back and look at other types of effects where a listener perceives one fused sound rather than distinct repetitions. In general, time delay effects can be thought of as systems with memory, and that's because as we're looping through and calculating the output for a given time sample, it can depend on the input at the current time sample, but also information in our signal from a previous time sample, as if it's been stored in memory. Up to this point, when we've been calculating changing a signal's gain, panning the signal, performing distortion, these could be described as memoryless systems because the output at a current time sample only depends on the input at a current time sample. Well, let's go ahead and open up our digital audio workstation and look at some of the foundational concepts of echo effects. Here in Pro Tools, let's look at some of the basics of creating echo effects. I'll be working with this recording of an acoustic guitar. It sounds like this. To create an echo effect, we need to use parallel processing. I'll demonstrate this two different ways. My first method is a manual way, where I'll duplicate this track. Now we have two identical signals running side by side in parallel. I'll use the one on the top as my dry, unprocessed signal, and the one on the bottom as my echo. What I need to do is introduce a time delay. I'll grab this region and shift it to the right on the timeline. Now when I play these signals back, you'll hear the first one and also a repetition or an echo. A common thing to do for echo effects is to change the relative amplitude of our two paths. Here I'll go in on our echo and reduce the volume here by a few dB. Next, what we can do is create a combined processed output signal by performing digital summing between our two tracks. I'm going to bus both of these tracks to the same location, and we can print them onto this output signal. Let's take a closer look at the digital summing that actually occurs. If I zoom in, the way that this process will work is for any given time sample, what we're going to do is take the current sample that's up here on our input track, the amplitude there, and add it with the amplitude that occurs on the echo track in order to get the same sample number down here on our output signal. More explicitly, we're going to go sample by sample, starting from the beginning, and do that same process for every single sample in our signal. Now, one thing we have to be careful about is what happens here at the beginning. Because we have amplitude up here on our input signal, but we don't have anything down here for our echo. In this case, what we can do is just add a 0 for each sample where we have something in our input, but we don't have anything in our echo. Same thing over here at the end, where we have the tail of our echo. We'll just add a 0 in up here for our input with the echo in order to create our output signal. Now, as audio engineers, when we're creating echo effects, we want to be able to control as a parameter the length of our time delay. There are a couple different time scales that we need to be able to work with. Sometimes we want to think in terms of seconds or milliseconds. So here on the timeline, I'll switch things over and we can look at the length of our time delay that gets introduced. So if we like, we can think of some number of milliseconds that will shift this over. We can look and see, okay, maybe it's 100 milliseconds, or maybe it's 500 milliseconds, it's half a second, or maybe it's an entire second long. So in some cases, we want to be able to control and make sure that the length of our delay is an appropriate number of seconds. Another thing that we can do is introduce a time delay that's synchronized with the tempo of our song. So in this case, our tempo is 103 beats per minute. What we'd like to do is shift this over by some amount. Maybe it's going to be an eighth note or a quarter note or a half note, some note duration relative to the tempo of our song. But really, as programmers, the way that we should be thinking about this is in terms of samples. So I can switch this over and we can look at what we can do is perform a time delay all the way down to our sample. So we could shift this over, maybe 10,000 samples would be this duration, or maybe 20,000. 22,000 is half a second. We go all the way up to like 44,100 samples. Right about here. So in this case, what's going to occur? We're going to add in maybe something right around 44,100 in our top signal, plus this delayed signal to get our output at sample number 44,100. Well, because we know that this echo signal is an identical repetition of our input signal, another thing that we could think about is that we're going to add sample number 44,100 here plus sample number 1 of our input signal in order to get our output at sample number 44,100. Then we move on to our next one, 44,101, and then sample number 2 in order to get our output signal at 44,101. So what this allows us to do is index our signal at different sample numbers in order to create an echo. So here, rather than just using the current sample, we can actually use one from the past at the beginning of our signal in order to create the echo. That's a few different ways to think about introducing an echo. This is a manual way. Let's move on to the second different way that I'll show you for creating an echo effect. I'm going to mute these two different signals and go back and we'll just use this single input signal here. And this time I'm going to pull up a plugin. So rather than the manual method, we can look at some of the parameters that exist in a common delay plugin for audio. So here, just like before, we're going to be able to shift the time delay in terms of seconds or milliseconds, but I want to have parallel processing. In this case, we'll change the relative amplitude of our dry signal compared to our wet by blending the two together here, down on the dry-wet meter. Then we can have a short time delay or a long time delay just by changing the number of milliseconds here. Or a long time delay. We also have the ability to create tempo synchronized delay by clicking these buttons here. We have the tempo of 103 beats per minute, so I could set it to be a quarter note. It is automatically going to convert that time duration to the appropriate milliseconds up here. So I could switch this over to an eighth note, and it will synchronize the amount of milliseconds, the number of milliseconds, to create an eighth note time delay. The last parameter that I'll demonstrate is this feedback control. As of right now, when we use this delay plugin or echo effect, we get a single repetition. As I turn up the feedback amount, we can actually get multiple repetitions that occur. So now we've looked at some of the foundational concepts about creating different kinds of echo effects.